So the stratosphere and troposphere are interconnected, of course, in the atmosphere, right? And this is a good representation of the polar vortex from this stratobserve.com website, and it shows it splitting, right, and the different impacts here. So I decided to put together a quick video. My name is Tim Ayler, meteorologist. I hope you enjoy this video and to talk about the stratosphere and all the talk about its effect on the troposphere and surface, right? It's really been on the internet a lot lately. And I hope you get something out of this. First, I'm going to talk about the layers of the atmosphere and go over this graphic in a little more detail for like 10 minutes or so. So take some time to watch this and hope you get something out of this. So let's get started. So I thought I'd post this graphic. I don't know if this is helpful or not. I'm going to move my uh, face up to the top left here. This shows the atmospheric pressure on the right and the altitude and the different levels of the atmosphere and the different vehicles that fly within it, let's just say artificial things, and the different natural, let's just say, things that occur in the different levels here. You can see the stratosphere is generally between 180 and like 1.7 millibar in pressure. So that's what we're talking about when we talk about the stratosphere and the troposphere between those two, right? So you can see how deep the troposphere is compared to most layers of the atmosphere, and it consists of about 60% of the atmosphere, and that's the atmosphere that we live in generally. Here's the top of Mount Everest up here. It reaches pretty high in the top of the troposphere here, and I'm showing you this because of stratospheric warming, right, and all the talk about that and the different levels of the atmosphere you would look at in the stratosphere to compare if it's warming or cooling, right? And so as compared to the rest of the atmosphere. It's a very complex interaction, and I'm sure there's not just one single thing that changes the rest of the atmospheric state. They all interact together. So models are only as good as they are, right? The data that they're fed into them and the formulas that they use, right? So if somebody can tell you that they know exactly what's going to happen with this stratospheric warming, they're wrong. But we do the best we can to interpret the data and pass it on as as we get it. So a little bit of a different thing talking about today. So so yeah, I'm gonna also go through some plots, the stratosphere here, like a vertical representation of it, and what's changed over the past couple of days with the stratospheric modeling, and why the temperatures will probably be warming up some east of the Rockies here in the coming days, for the foreseeable future at least, till the middle towards the end of February. So quite a big change in the from the current pattern where it's just been cold along the east and warm out west. So kind of flip around here. So we'll talk about that as well. So here's a little different graphic of the it shows basically the same thing here. The tropopause, troposphere up to um, you got the tropopause, which is in between the troposphere and the stratosphere, um, right? And then the stratosphere encompasses between like 1 and maybe 130 or 40 millibars, right? Um, right. So 1,000 generally at the surface. You see Mount Everest here. So this gives a pretty good idea where the stratosphere ends and begins, and the troposphere does. So, and then you see how temperatures look like they rise, right? And as you go further up, but the air is so thin that yeah, potential temperature's higher, but the air is so thin that it's very cold. It feels cold. So don't let this fool you about the temperature at this altitude. So anyway, um, my washer's going off there making noise. Sorry about that. But yeah, this is a pretty good graphic as well. And I hope you get something out of this. So I wanted to show you a couple things on the stratosphere. I know this is getting into the weeds here with it, but if you're so inclined, um, let's dive in here. So I showed you the chart with the millibars, right? 1 millibar is way up there. 150 is close to the troposphere, right? So, so you move this through maybe like the 7th, let's just say. Uh, so this is 7 February at 150 millibars, right? And you move up to the up to 1 millibar. You can see it looks like the stratosphere at the low is split here, right? If you go down to 150 millibars, you see how it impacts the top of the troposphere, right? Um, right, but so the minimum maximum temperatures here are northward of 30 north, so not huge impacts here, right? Let's go further up here, but you see how the higher levels of the atmosphere are colder, right? The vortex is really split here. Let's move through time, and you see how it towards the end of it, how it moves over. Uh, it's split between, let's say, like the different hemispheres, but not over North America, right? Go down here to the lower levels in the troposphere. Um, you have generally warmer temperatures, right? Here, where the United States is and Canada, right? And then colder temperatures look like over Asia, if I got this right. Looks like it, Asia and Europe. So let's look at the vertical profile here real quick. So here's the United States. Here's the polar vortex at 0 degrees, right? And the different levels, potential temperature. I know it looks weird, the values go down as you go down, but it's just the way it is with potential temperature, okay, in Kelvin. And I guess it makes sense, right? But it's kind of stretched out here, okay? So we're gonna move this through time, consolidate some. Remember how we talked a few days ago about it splitting? It still does that, right? But interesting how it has this one up here. But you see how part of the polar vortex rotates over the Asian continent, and then it works to consolidate again uh, uh, over time here, with not much left over the continental U.S. So maybe part of this explains why we aren't getting as much intrusion of cold air, at least in the eastern U.S. But you can see along the western U.S., it's really hard to make this out. So let's go 90 degrees. So we have the northern hemisphere facing us. Okay, going through time with this. It's 7 February. You see how it's split, maybe over the northeastern part of Canada here. All right. Excuse me. Swings around. You see the upper levels of the atmosphere, the stratosphere up here. It looks like the above the western part of the U.S. It's really hard to tell here. Let's look at this real quick. Yeah, let me do 180 degrees as well. Yeah, it's really hard to tell from this. I'm gonna do 270. Hard to really make this out. But either way, you see how it's kind of stretched, right? And then whatever's left of the circulation above um, looks like it's over the western part of the continent of the U.S. So long-winded discussion here, but hopefully this gives you a good understanding, a little bit more about the polar vortex and what it's doing and why the forecast is changing. And there's other things that come into play with this as well. So I could spend all day talking about this, but I hope you all got something out of this. And I'm going to include this in today's video, as well as put a special segment out on YouTube as part of this as well. So I hope you got something out of this video. It's kind of technical in nature, but hope I explained it well. If you have any comments, questions, or concerns, or just want to ask what I'm talking about here, what the heck you talking about, I'll be happy to answer those. Hope you have a good day, and God bless.